Ang pag-uusapan natin ngayong araw ay ang konsepto ng inverse square law. So, maraming nagtatanong, paano ko i-compute kapag ang missing ay yung second distance o kaya ang missing ay yung second intensity ng radiation. Okay? So, ngayong araw, isa na namang kaalaman o knowledge ang ating pag-uusapan. So, ito ang knowledge, ideas, and experiences ng isang RadTech. Okay? So, ang una nating tatalakayin ay magbalik tanaw tayo dun sa cardinal principles of radiation protection. Konti lang. Ang cardinal principles ng radiation protection ay ito yung principle ng time, distance, at shielding. So, ngayong araw, ang pag-uusapan lang natin ay isang bahagi ng konsepto ng principle of distance. So, this is the principle of distance. No? It was said that principle of distance is the most effective means of reducing radiation exposure. So, during exposure, the patient is the extended source of radiation. Bakit? Kasi yung pasyente yung pinanggagalingan ng secondary scatter radiation. So, kapag tumama na yung radiation sa pasyente, i-scatter naman niya yung iba, no? Because radiation, as it interacts with the patient, no, with the tissues of the patient, it scatters in all direction. So, RadTechs are very careful in choosing the right, just the right amount of technical factor, so much so that we reduce the chances of increasing the scatter radiation. So, according to Bushong, patient is the single most important scattering object. Dahil sa kadahilan ng yung pasyente nga kapag tinamaan ng radiation, hindi naman lahat yun ay diretso dun sa image receptor kung saan ito yung kumukuha o nag-capture ng image na kinukuha natin kapag tayo ay nag-e-x-ray, no? Kung hindi, marami sa mga dati ay primary beam ay nag-i-scatter mula dun sa pasyente. So, diretso na tayo dun sa konsepto ng inverse square law. So, inverse square law states that the radiation intensity varies to the square of the distance. So, X-ray intensity is inversely proportional to the square of the distance from the source of radiation. So, it was said that when radiation intensity decreases, then you must increase the distance. So, kung gusto mong i-reduce yung radiation intensity, dapat lumayo tayo mula dun sa source. So, inverse square law holds true to primary beam. It is applied to distances greater than 7 times the longest dimension of the source, and it is true to secondary scatter radiation after about 1 meter. So, take note that if the distance is cut in half, intensity is multiplied by a factor of 4. Therefore, the distance between the radiation source and person, pag mas malapit, magmumultiply yan by a factor of 4. So, tataas, no? Lalakas yung radiation intensity. So, if the distance is doubled, no? If the distance is doubled, the original intensity is reduced to 1/4. So, kapag lumayo tayo, doblehin natin yung distance natin mula dun sa source, radiation source and person distance. Marireduce natin by 1/4 or by 25% yung ating radiation intensity. So, this is the formula for inverse square law. It is also known as the intensity-distance relationship. So I1 stands for the first intensity, I2 is the second intensity, D2 is the second distance, and D1 is the primary distance or first distance. Example, at a certain technical factor, a radiation intensity of 100 milligray at a distance of 3 meters is produced. What is the intensity at 6 meters if other factors are constant? Of course, using the formula I1 over I2, D2 is squared over D1 is squared. So we have 100 over x is equals to 6 squared over 3 squared. So ito yung mga given natin, no? So we have 100 milligray as the first intensity, 3 meters as the first distance, and 6 meters as the secondary distance. So moving on, we have to get the answer of 6 squared and 3 squared. 6 squared is 36, 9 squared is 3 squared is 9. So we just cross multiply the components of the equation, no? Yung numerator ng first equation, first fraction natin, and the denominator of the second fraction. So ganyan yung nangyari. So 36x is equals to 100 times 9. So ito siya, nag-cross multiply lang po tayo. So 36x is equals to 900. So since we have 36 here, then we have to divide it by 36, no, on both sides of the equation. So we have 36x divided by 36 is equals to 900 divided by 36. So i-cancel out lang natin yan. So ang natitira ay x. X is equals to 900 divided by 36 is equals to 25. So next example, if at 4 meters, intensity of radiation is 8 milligray during lateral lumbar X-ray, what is the distance if the intensity is 2 milligray? So using the formula, we have 8 divided by 2 is equals to x squared divided by 4 squared. So take note that 8 is your first or primary intensity, while 2 milligray is your secondary intensity. 4 meters is your primary distance, while your secondary distance is unknown. So ito yung hahanapin natin ngayon. So cross multiply 2x squared and 8 and 16. So we have 2x squared is equals to 8 times 16. So 8 times 16 is equals to 128. So you have 2 over here. So may 2 ka pa dyan. I-divide mo ang 2 on both sides of the equation. So you have 2x squared divided by 2 and 128 divided by 2. So you have to just cancel out 2. So you have x squared is equals to 128 divided by 2 is 64. So since may squared tayo dyan, kailangan natin kunin yung square root ng x, no? So the square root of x squared rather. So kukunin natin yung square root ng x squared, ganun din dun sa 64 para balance yung equation natin. So you just cancel out square root and squared, no? So you have x is equals to the square root of 64. And the square root of 64 is 8. Okay, so you have to try this. An X-ray source gives an intensity of 90 mR at a distance of 2 meters from the source. How far from the source should the worker stand so that the intensity will only be 40 mR? Okay? So, kung nagustuhan nyo yan, abangan ang mga susunod pa nating tatalakayin sa channel na to, sa page na ito. Maraming salamat sa inyong pagsubaybay. Naway matuto kayo araw-araw. Bye-bye!